These are the notes for section 7.4. The title is Mean and Variance of Random Variables, and you're also going to learn about combinations of random variables. So the first thing we're going to do is look at the mean of a discrete random variable and the variance for a discrete random variable. Random variables can be displayed lots of different ways, sometimes in a table, sometimes in a picture like this. And because this is a histogram type of picture, it has a center, a shape, a spread, and unusual. And today we're going to focus in on the center and the spread. The formulas that you need to know are here and here. These are given to you, so you don't need to memorize them, but they are pretty straightforward and easy to memorize. The mean is defined as every number times its associated probability. So if I know that 0 occurs 5% of the time and 1 occurs 65% of the time, I can weight each of these outcomes by their probabilities and add them up. 0 times 0.05, 1 times 0.65, all the way up to 3 times 0.1 gives me an average. The example we're doing here is the number of whole chocolate chips in Mini Chips Ahoy. A few years ago, I guess this was a controversy because in Mini Chips Ahoy, they used full-size chips and some of the cookies got no chips. So since then, they've changed it. But back then, on average, Mini Chips Ahoy had only on average 1.35 chips per cookie. To figure out the variance, just like we did earlier in the year, take each data value, compare it to the mean, square to find the difference, and now we're going to weight it by its associated probability. So 0 chips compared to the mean of 1.35 squared, weighted by 0.05, plus 1 chip compared to the mean of 1.35 squared, weighted, etc., gives you 0.5275. Standard deviation is 0.7263. In this section, variance is going to become important, but for right now, the spread is 0.7263. Second example is a little bit more intense, so we're going to need a calculator. This is the New York Lottery Quick Draw Keno game. At the end of the lesson, you're going to learn how a couple of people made some money based on the New York Lottery making a little bit of a mistake in their Quick Draw Keno game. But for now, what you need to know is if you match 0 or 1 numbers in the Quick Draw Keno, you don't win any money. If you match 2 numbers, you win $1. If you match 3 numbers, you win $5. And if you match 4 numbers, you win $55. So it's not anything like Lotto that generates a ton of money, but you'll see in a few minutes that some people did win a lot of money. So on average, how much do I win? Well, we're going to combine these two categories together because I don't win any money. Their combined probability, 0.308 plus 0.432, is right here. In our calculator, we're going to put the amount that we win in L1 and the probability that we win that in L2. So winning $0 occurs about 74% of the time. Winning $1 occurs about 21% of the time. $5 that, and $55 that. You should type these numbers in your calculator. Be careful though. Type the sum of these two. Don't just read it off the screen over here. Type the sum of these two into the first spot in L1. Type this six-digit number into the second spot in L2. Third place, fourth place. To find the mean, you're going to go stat, calculate one variable stats. Hopefully this screen shows up. And then to find the variance, we need to do a little bit of work with this number here. So, to see how this goes, I have the numbers in L1 and L2. I'm going to do stat, go over to calculate, one variable stats, press enter. And now what needs to happen is for the first time we need to enter two lists. We want the average of list 1, but we want to weight it or use a frequency that occurs in list 2. So for the first time we have both of these are important. I want the average of L1, but weighted by L2. So those are entered in correctly. I'm going to press calculate, and this screen matches what we had in the PowerPoint. So on average, I'm going to win 59 cents, almost 60 cents per game, and my measure of spread is 3.19415. If I need variance, I need to get that standard deviation into the into the home screen so that I can square it. So what I'm going to do is vars, go over down to statistics. When I press the vars button and move down to statistics, which is choice 5, press enter. I'm going to go down and choose the fourth option, which is the standard deviation. Enter. And now from the home screen, I'm going to square that number, and that produces the variance of 10.2026, which I can see is written down right here. 10.2026. So again, to get one variable stats for a discrete distribution, you need to put in L1 comma L2, and then to get the standard deviation turned into a variance, you're going to press the vars button, go down to statistics, and square this number here on the home screen. Okay? So moving on, we're going to come back to that example. How do we find the mean and variance of a continuous random variable? Well, good news is we can't. Okay. For a continuous random variable, we need calculus. The mean is defined as the antiderivative of x times the probability function of x. Can't do that. We can't do that. So in most cases, you're going to be given the shape, the center, and the spread of a distribution, and then you just use that to draw a picture. The shape is normal. That's what this n means. The center is 64.5, and the spread is 2.5 for each standard deviation from that center. Okay, so that's continuous. Next topic, transformations and combinations. If I have one random variable, I could do a couple different things with that random variable. I could multiply that random variable, or I could add to that random variable. That's called a transformation. In this case, it's called a linear transformation. It's kind of like your y equals mx plus b. If I know the mean of this random variable x, I can find the mean for our new random variable y by simply plugging the mean into this formula here. So this statement here says the mean for your new random variable y is your old mean from x times whatever you're multiplying by plus whatever you're adding to. And a great example of that is converting something from Fahrenheit to Celsius or Celsius to Fahrenheit. Here's a rule. If I have a temperature in Fahrenheit, I multiply by 5/9 and I subtract this 160 over 9, and that gives me Celsius. Since that's the rule, if I have a random variable measured in Fahrenheit, and if I know the mean of that random variable measured in Fahrenheit, I can take that mean, plug it into the rule, and figure out the mean for the random variable in Celsius. Okay? Standard deviation is a little bit different. I need to work in variances, not in standard deviations. I need to work in variances, and only the b number, only the multiplication matters. The addition does not affect the spread. Okay? And one way of demonstrating that is imagine you had a bunch of numbers between my two fingers. Okay? If I decide to multiply all the numbers in my data between my two fingers, both the low and the high side are going to get multiplied, and the gap between them increases. Okay, so multiplication, that b number will increase the spread if I decide to change. But if I take my original data and only add to it, if I add the same number to all my data, it's going to move up the same amount, all of them, but the spread between my fingers is not going to change. So addition does not change spread. So that's why the a number in the linear transformation does not appear in the transformation variable. So back to the Celsius and Fahrenheit example, if I know that this is the rule, and if I know my Fahrenheit spread is 3, I can plug it into b squared times standard deviation squared. That gives me the new variance right here, and then the new standard deviation is just the square root of that. Okay, you'll get plenty of practice doing that, but what happens is addition affects the mean, multiplication affects the mean. Addition does not affect the spread, multiplication does affect the spread. The other thing you can do with random variables is combine them. So imagine you're at a chemistry experiment where you know on average how long phase 1 takes and how long on average phase 2 takes. If you want to know the average for the total part, how do you figure that out? Well, for means, everything is very straightforward. You would just take the average for phase 1, add it to the average for phase 2, and then you'll get the average for the total part. If your process is subtraction, then subtraction works. Okay? Variance, again, has a couple other tricks. First issue is, if I know the variance for the first and the variance for the second, regardless of whether I'm adding or subtracting my random variables, variance always adds. Okay? You cannot subtract variances. And if you think about that, that makes sense, because imagine the variance for the second one is larger. You would have a smaller number minus a larger number, which would be negative, and spread can't be negative, it must be positive. The other rule for variances is that the two random variables you're combining must be independent. There's a more advanced topic called covariance, which we don't study, but for now, you can only use this formula if your two variables are independent. How do you know if they're independent? Well, generally you're told whether or not they're independent. So the example we're going to use is a track team. Imagine we have a relay team where runner 1, 2, 3, 4 all have average times and measures the spread for their 100-meter race. And I want to find the mean and the measure of spread for the total time for the relay. So moving on to the next page. The rule is total for the team is going to be first runner, second runner, third runner, fourth runner added together. Everything with means makes sense, so I can just take those 4 average times, add them together, and say the total on average is going to be that. Everything with means is going to make sense. To figure out the measure of spread, I need to take these standard deviations and first convert them all into variances. So I'm going to square all those standard deviations. I get a total variance of this, and then the standard deviation is the square root of that number, which is 4.168. Okay. Later on, we'll be using the center and the spread to calculate probabilities, but for now we're just concerned with finding these two numbers. And one thing I want you to notice is that a squared plus b squared does not equal a plus b. Sorry, the square root of a squared plus b squared does not equal the square root of a plus b. So you need to go through this process. It's like the Pythagorean theorem. Okay, so last example, we're back to the gambling thing. We're going to use the two topics we just talked about, which is combinations and transformations, and apply them to the 1997 New York Lottery promotion. So somebody decided that on Wednesdays they were going to double the winnings. So they didn't increase the cost of playing the game, but they decided to double the winnings. Okay. Earlier we saw that on average your winnings was 59 or 60 cents and the spread was about $3.20. So the two questions we need to answer is find the rule for the profit and then find the rule for Big Dipper Wednesdays. Now profit means I'm now going to factor in the cost of me playing this game. So the average winnings was 59 or 60 cents, but it cost me $1 to play every time. So my rule is my profit F is my winnings minus the $1 that it cost me to play. What's my new mean? Take the old mean, subtract 1, or add a negative 1, I get negative 0.4265, which means on average I expect to lose 40 cents every time I play. Okay, that's why gambling exists. On average, you're going to lose money. Now, there is a measure of spread, winds up being $3.20 roughly. That's why we gamble, because even though on average I'm going to lose, if I can just get one standard deviation above the average, then that means I'm going to make money. So again, the formula from the rule is only the b number matters, which is in front of the variable 1. B squared plus the old spread squared, 10.26 square root is $3.19. And here is what happens on Big Dipper Wednesdays. If they're not going to increase the price, I'm still going to cost me $1 to play. But if they double my winnings, my profit D on Big Dipper Wednesdays is 2W minus 1. Take the mean, plug it into this rule, 60 cents times 2 minus 1. My average is now a positive 0.1946, and that's very important. If you ever see a gambling game where your average winnings factored in with the cost of the game is positive, you should play that game as much as possible. Your average is positive, which means in the long run you'll be winning money. For each game played, we expect a profit of 19 cents on average. To figure out the new spread, take the B number, square it, multiply it by the variance, and we get this. The variability increased, but that's okay. If I know that on average I'm going to win money, having a bigger spread means that there's a chance for me to make even more money. So to convince you that this really happened, I have a article to show you from the That's it.